Hello students, welcome to the fourth lecture where I'm going to be talking about interpolation. So what is interpolation all about? Alright, so like any other thing that we've looked at, we always start with, we are going to start also with some data. Suppose we've collected this following data for the volume, maybe for say an experiment that's been happening, and the volume produced in this experiment was recorded for these times. Okay, so an interpolation question would be what is the volume at time 1.7, right? So as you can see, the recording was done at 1.6 and then at time 1.9, okay, and not at 1.7, right? So what would be the best estimate for the volume at when the time is 1.7, right? So this is mainly the question of interpolation, right? So we also have to make a distinction between interpolation and extrapolation. Okay, with interpolation, the point is between the times. Okay, so as you can see, 1.7 is between 1 and 2.2, so that makes it an interpolation problem. If the 1.7 was, after the 2.2, say if we wanted to find the volume at say 3 at time 3, then that would be an extrapolation problem. So in this chapter and in this course, we are only going to be looking at interpolation. So the problem of interpolation can also be illustrated through this diagram. Okay, this is a picture that I found somewhere on the internet, which illustrates the idea, right? So the data that we have here are the gray dots that we have. Okay, so the gray dots are the data, for example, these values. Okay, and the point of interpolation is to actually find the curve that goes through all these data points, right? The curve in green is what we find by interpolation, right? So once we have that curve there in green, then we can use it to find the y's for values between these x's. So for example, this value for this time here, we can find the corresponding y value, right? So that's interpolation. That's the idea of interpolation. And if you look into your notes, there is theory to support that you can always do this exercise. You can always find a curve that goes through these points, right? And ideally, we are looking for polynomials. Those are the sort of curves that we want to go through all these points. So we want polynomials. Polynomials are very important. Polynomials are very good in this sort of work because you can always do interesting things with them. You can always find derivatives, for example. If you are working with polynomials, you can find the derivative of a polynomial, or in other words, you can differentiate a polynomial as many times as you want, which is why we want polynomials. So we're going to be looking at how we find these polynomials, different polynomials, and the implication on interpolation, right? Okay, now let's look at the first form of interpolation. It is called linear interpolation. This is the easiest. So you have two data points, only two data points, and the only curve, the only unique curve that you can fit between 2 points is a straight line. Okay, so for that reason, we are going to look for a polynomial of this form. So this one means it's a first degree polynomial. It means the highest power that you see for x is going to be 1, right? So if you have two data points, then you fit a straight line. In other words, you fit a first degree polynomial. So now if we substitute for these 2 points here in this polynomial, this is what we get. So if x here is x naught, then we're going to get a naught plus a1 times x naught, right, which is what we have here. And this, the value at x naught in our polynomial should be equal to the data point there. Okay, so if we substitute x naught, we should get the f, which is what we have here. So the polynomial has to pass through this point. This is what it means here. The same thing happens with x1. We're going to substitute x1 in this polynomial. This is what we get, a naught plus a1 times x1. Okay. Again, the value at x1 for this polynomial should also be the same as what we have from the data. All right. So in other words, when we do the substitution at x1, it should be the same as the data point at x1, which is this. So in other words, the polynomial has to pass through. It has to pass through. So the value of the polynomial, the green line at this point, is the same as you can see with the data. So they should correspond. So that's basically what I've done here. So that means you end up with 2 equations in 2 unknowns, a naught and a1. You can simplify, you can solve these equations for x naught and for a naught and a1. So if you do that, you're going to get these 2 values. Now if you substitute the a naught and the a1 that we have found here back into our polynomial here, we have this polynomial. So our polynomial has to be like this. So this gives you a formula for doing linear interpolation between 2 points, right? There is not much reason why you would want to memorize this formula, because you can always go through the process of fitting your 2 points and then find your a naught and a1. So there is not really a point of trying to remember this, all right? But let's look at an example to see how these things work. So the question here is to estimate log 2 using linear interpolation given these data points. So these 2 are your 2 data values, x naught and x1. It is an interpolating problem because the 2 is between 1 and 6. So each time you look at an interpolation problem, make sure it is interpolation. Make sure the point here, the 2, is between 1 and 6. If it is outside 1 and 6, then that's extrapolation, which is another subject. All right? So always make sure you're working with the interpolation problem. All right, so here's the data, the x naught, the x1, the corresponding values of the f's here. So our f is log 1 corresponding to 1. Here you have log 6 corresponding to 6. Okay, so using the formula that we have found here, the formula is this. So log 2 would be p at 2, okay, 2, which is f, the first y value that we have, it's log 1. This would be the second y value that we have, that's log 6, okay. We are finding it at x equal to 2, x naught is 1, okay. Simplify that, this is what you get. Now if you punch in your calculator and try to find log 2, you find that this is what you get. So using linear interpolation between 1 and 6, we got this. The exact value is this, okay, which is quite bad, but that's expected because linear interpolation is the simplest form, but it is a good starting point. Then the next thing that we want to look at is quadratic interpolation. Right? So I'm going to pause the video and then start from there.